So I am setting up this voltmeter because I hate these probes. Although wisdom would probably dictate that I should use those probes and not use anything else. But I'm hooking up the probe to an alligator clip, and then I'm hooking up the alligator clip to a snap circuit thing, and then same thing with the black probe to an alligator clip and to a black snap circuits probe connector. Doesn't seem to want to pause. Why? Oh, okay, now I've got that hooked up. I'm going to set this on milliamps. Milliamps to amps, so that it's ready to record milliamps. And I've connected across through the circuit through the 1000 ohm resistor. And I'm going to hit the switch over here and see what this measures in the milliamp setting. And it measures 0.001, I think, milliamps. Oh, it just says amps down there. There's a little, I think I see an A. Oh, how do you see that A? There's a glare, and it's not picking it up on the camera. Alright, I think possibly what the culprit might be is this transistor here, which is preventing very much current from going through. So I'm going to remove that transistor and replace it with a short guy there, and then see what happens in the milliamp setting. It's still very small. What happens if I set it on microamps? Still very small. This is kind of disappointing. Okay, here's more like what the circuit that we need is. Just a 3-volt battery connected to the 3-volt bulb, and when I hit the switch, we see that we have 0.175 milliamps flowing through the bulb. And with this guy, hitting the switch seems to have blocked off all current completely. So maybe that one doesn't have a working ammeter inside it. Alright, let's try it again, this time on the fused side. And I hit the button. Now it says 169.4. Okay, I'm starting to figure something out. I thought I had something figured out, but so this one measures better when it is on that unfused side. So it's measuring 0.176 amps here. When I hook it into there, oh, this one's just reversed from that. It's got the volts on that side and the amps on the other. So that's why it was confusing. Okay, I'm trying something different. Connecting up a resistance, a capacitor, a switch, and a LED bulb. So I want to see if this should turn on the LED bulb, and it will eventually shut off as the current flows through it, because all of that voltage will be across the capacitor instead of the LED bulb. Current will stop flowing. And this is a 10,000 ohm resistor, so, or is that 100,000? Oh, it's 100,000. So it's quite possible that there's not going to be enough current to get into there at all. But let's try it, see. I don't think I'm seeing anything, so I'm going to have to go down to a smaller resistor up here because I'm not seeing any light come out of that. Okay, so I switched to the smallest resistor we have, and you can see that when I hit the button, oh, I fried it. Did I fry it? I fried it. Oh dear. I fried the diode because it just flashed really nice and bright, and now it doesn't light at all. So I screwed up there, boy, big time. Okay, now I'm going to try, without the other battery, 5,100 kilo ohm resistor. See if this does anything when I do it. Nothing. Nothing. Really? Nothing? Oh, because maybe the battery's not strong enough. Or 5,100. What do I have? Oh, I've got a 1,000. Okay, 470 microfarad transistor. 1,000 ohm resistor. There we go. That was beautiful. Now, does it discharge? Oh, you know what we need to do? We need a discharge path for the transistor. That's what we need. So let's put a discharge path for the transistor over here. And that will be just... that would be, I guess, 2 of these stacked on top of each other. No, we want a switch, right? A switch. And where's the switch we want? We'll use this one. Okay, it's getting a little long.